morning children, and welcome back to your chemistry class. Today we shall begin with a new chapter, that is elements, compound and mixtures. And as far as I remember, this will be your last chapter for your first term. So there are millions of substances in this world, as we all know. So to study them systematically, they have to be classified in different ways. You have already learned what is matter, its classification into solids, liquids and gases, and the different changes of the states of matter. But matter can also be classified chemically on the basis of their composition. It can also be classified on the basis of the properties, then similarity, maybe dissimilarity, and even the uses into elements, compounds and mixtures, right? So let us over here revise and recall all our previous knowledge. Okay, so elements and compounds, what are they? Elements and compounds, they are pure substances, isn't it? Pure substances. And mixtures, they are impure substances. Fine, this much you remember. So if elements and compounds, they are pure substances, we can also say that they are homogeneous substances. Fine, they are homogeneous. Now what do we mean by this word homogeneous? Homogeneous word means that they have similar property throughout their bulk. Okay, elements and compounds, they have similar property throughout their bulk. Okay, for example, if you talk about an element iron, right? So iron gets attracted by what? Magnet. Now if you take a piece of iron near the magnet, it gets attracted. You break that iron piece into two parts, still it will get attracted. You make it into iron filing, then too it gets attracted. So what do we say? That every particle that is present in the iron, it is similar. That means it has similar property throughout the bulk. Similarly, I am talking about compounds. Compounds like your salt, NaCl, or any other salt, KNO3, they also have similar property throughout their bulk. Explaining about elements and compounds in detail, we'll go further in this chapter. But presently what you need to understand over here is that elements, compounds, they are pure substances and they are also homogeneous. Homogeneous word means that they have similar property throughout their bulk. Clear? Now let us talk about mixtures. As I told you, they are impure substances. Now impure substances, they can be homogeneous as well as heterogeneous. These mixtures, they can be homogeneous, they can also be heterogeneous. Okay, now what do we mean by this word heterogeneous? Homogeneous is very clear to you. Now heterogeneous means they do not have similar property throughout their bulk. So let us take few examples. Where do these mixtures, they occur as homogeneous or they occur as heterogeneous mixtures? Okay, so you know about air. What is air? Air is a mixture. But what is air made up of? Air is made up of oxygen, carbon dioxide, nitrogen. But do we find all these gases in a different corner of your room? No. We just see there is a air. So that air is your homogeneous mixture. That is, it has similar property throughout the bulk. Clear? Now coming to a heterogeneous mixture. Heterogeneous mixture could be, if you take iron filing, okay, which is grey in color, and you take some powdered sulfur. Okay, I am talking about iron filing, which is grey in color, and we also take some powdered sulfur. This is yellow in color, and put it in a dish. So what are you going to find? You will find mixture which is clearly visible through your eyes. Some particles are grey over here, some particles are yellow over here. Okay, so that means they do not have similar property throughout their bulk. This is what I meant to say, that they are heterogeneous in nature, right? You may even take say water and add sand to it. That is again your heterogeneous mixture, because it does not have similar property throughout its bulk. So I hope till here all these points are very clear. What do we mean by pure substances, what are homogeneous, heterogeneous substances, and which substances are pure or which are impure substances. Clear? Now let us begin with the pure substances, that is elements. So what do we know about elements? Today we are going to talk only about elements. I'll go little slow with the video, okay? So what are elements? As I told you, they are pure substances, and they cannot be broken down into still simpler substances by any known physical or chemical method. So I'm writing it down over here. It is a pure substance which cannot be broken down into still simpler substance by any physical or a chemical method. Is this point very clear? So these elements, they consist of only one kind of atom. What do we conclude? That therefore they contain only one kind of atom, right? So now what are the elements divided into? These elements, they are further divided into four parts. What are they? They are metals, they are non-metals, they are metalloids, and they are noble gases. Okay, so these are the four different types of elements that we are going to study today, right? So let us begin with metals. Coming to metals. Okay, we are talking about what? We are talking about elements. So what do we know about metals? They are bright metallic luster. They are good conductors of heat and electricity. They are ductile. What do we mean by ductile? That they can be drawn into wires. So let me write down all these properties so that you can easily learn them. So what was the first one that I said? That they have bright metallic luster. They have bright metallic luster. Okay, then what did I say? They are good conductors of electricity, good conductors of heat and electricity. Then they are ductile. They are ductile, as I told you. So what do we mean by this word ductile? That they can be drawn into wires. Clear? Then they are malleable also. They are malleable. What do we mean by they are malleable? That means they can be beaten into sheets. They can be beaten into sheets. Okay. Then examples I'm going to tell you at the end. Then they have high melting and boiling point. They have high melting point and boiling point. Why do they have high melting and boiling point? Because their molecules are very closely packed. Okay, so they require higher temperature to break, and therefore they have high melting and boiling point. Then we can say that they are solids at room temperature. they are solids at room temperature, right? Then they even make sound when they are struck with a substance. So what can we say? They are sonorous. They are sonorous. What do we mean by sonorous? That they produce sound when they are struck with something. Okay, so some good examples of metals could be, as you know, it could be gold. Okay, then copper, iron, then aluminium, then silver, then it could be any other, uh, tin, and so on. But do remember, they are ductile, they are malleable. Here we have some exception. Exception is that zinc is an exception. Zinc, we know it is a metal, right? But it is not ductile, neither malleable. Why? Because when you beat, it turns into powdery form. That means you cannot draw it into wires, neither you can beat it into sheet, right? So this is your exception, which does not show your ductility or malleability, right? Then another important point, I said they are solids at room temperature. Here also you have an exception, mercury, right? Mercury and gallium. These two are though termed as metals, but they appear as liquid at room temperature, are found in liquid state at room temperature. This is all what you have done in your previous class, right? Then tungsten, as I told you, they are good conductors of heat and electricity. But over here there's one more exception. What is that exception? That tungsten, right? Tungsten, which is W. Its symbol is W. It is a poor conductor. Is a poor conductor of heat and electricity, right? So this was all about metals. Metals, you know, they have bright luster, means they have a shiny surface. So all this was all about metals. Now let us talk about non-metals. Now let us talk about non-metals. Okay, so what do we know about non-metals? They do not have luster, right? Non-metals do not have luster, but exception is there. What? Like graphite, except like iodine or even and graphite, they show luster. That means they have a shiny surface. Okay, next we come to, they are poor conductors of heat and electricity. They are poor conductors of heat and electricity, right? But do you know there is an exception over here also, except what? Graphite or carbon. Graphite is formed by carbon, right? They are good conductors of heat and electricity. Graphite is a very good conductor of heat and electricity. Then they are not ductile. They are not ductile. They are neither malleable. They are not malleable also. Okay. Then they have a low melting and boiling point. They have low melting and boiling point. Now why do they have low melting and boiling point? The reason is that they do not have strong intermolecular forces between them. Okay, therefore they have low melting and boiling point. Then the most important point about non-metals, that they can exist in all the three states. In metals, what did we study? They were only solid, right? But exception was there, mercury and gallium, they are found at room temperature, but non-metals, they exist in all the three states of matter. That is, let's see, if it is in solid, then we are talking about like sulfur, phosphorus, iodine, so many non-metals, they appear as in their solid form. Then liquid is the only example is your bromine. Bromine is not a gas, it appears in the liquid state. When heated at high temperature, it turns into gaseous form, but it is liquid at room temperature. And then we talk about gases. Gases, you know, hydrogen, oxygen, nitrogen, chlorine, all these are gases. Okay, now let us now talk about metalloids. Okay, now metalloids, they always are found between metals and non-metals, right? So they have the characteristics of both metals as well as non-metals. So I should write over here the elements which exhibit both the properties of metals and non-metals, right, are called metalloids. What are they called? They are called metalloids, right? Now some of the examples over here could be like your arsenic, okay, then we have antimony. Antimony is there, bismuth is there. So handful of your elements are metalloids also. Germanium is also there. Lastly, we come to noble gases. Now noble gases, why are they called noble? Do you know? Because noble people, they hardly interact with other people. So these noble gases, they do not interact with any of the known elements. Therefore they are named as noble gases or inert gases. They have inert nature. They do not react with any other element. Therefore they are termed as noble gases or inert gases, right? And they are always in their gaseous state. Are found in gaseous state. Yeah. Then they are chemically inert. They are chemically inert. Now why are they chemically inert? Because their outermost shell, okay, outermost shell, or we also call as valence shell, has 8 electrons. That means it follows the octet rule. 8 electrons means it is completely filled, and therefore it does not show any sharing, okay, and hence it has no valency, and therefore it is inert in nature, because they are chemically inert, because the outermost shell has 8 electrons. Okay, they occur free in state in the air and in the atmosphere, but in very small amount. That is why it is called as a rare gas. They occur in free state in the air or atmosphere in small amounts, okay? Therefore called as rare gases. Clear? They, one more important, they are monoatomic in nature. They are monoatomic in nature. So what do we mean by monoatomic? That means They are made up of only one atom. So example could be like your helium, argon, neon, krypton, radon, and so on. So these are some of the examples over here. So coming to how many elements are known to us. You know, widely distributed in the Earth's crust in free state, we find around 118 elements known to us, out of which, what did I say, 118 elements known to us, out of which around 92 they are naturally occurring. Okay, they are naturally occurring, and around 26 they are artificially created. They are artificially created. Okay, so elements in their pure form we have already understood. Now one very important point that I'm discussing with you: why are elements called as pure substances? Why? Because they have fixed melting and boiling points. They may or may not chemically react with another element or compound. As I told you, they may react means metals, metalloids and non-metals, they react. They may not react means noble gases, they do not react. So again I repeat, they may or may not chemically react with another element or a compound. So till here it's very clear to all of you. Okay, so I wind up over here. Next time I shall come back to you with the compounds. Thank you.